Hi everyone. Today we're going to be taking a look at what is meant by the domain and the range of a function. So in your notebook, please put today's subtitle, Domain and Range of a Function. Let's start with a domain. It is the set of all elements from the source set that actually have images. So it may not represent all the objects in the source set. It's only the elements that have a corresponding image. The range has a very similar definition, except for one big difference. The range is very similar to the domain, except that it refers to the elements from the target set that are actually acting as images. So, let's take a look at the difference between a domain and range with a very quick example. So I'd like you to put EX, please. Alright, in the example, what I'm going to do is we're going to draw two mapping diagrams. There's the first bubble. We'll call that set A. And here's the second bubble. We'll call that set B. And if you can recall from what a mapping diagram is, the left set is usually the source set, and the right set is usually the target set. And I want to identify that the two sets are connected with the function f. You can call that function anything. Now, in the source set, I'd like you to put 0, 1, 2, 3. And in a target set, I would like you to put 0, 1, 2, 3, 4. I would like you to connect 0 with 1 and connect 1 with 3. Alright, this is a very nice example to illustrate the difference between domain and range. Well, let's look at all the objects in the source set. We have 4 of them. I want you to put them down. So set A, and we write it like this, with the squiggly brackets. We say that set A consists of the following object, 0, 1, 2, and 3. Now, the domain is not every object that is inside the source set. The domain only represents the objects that actually have connections to an image. So in this case, if you look at the mapping diagram, only 0 and 1 have connections to objects in the target set. So the domain, therefore, is not 0, 1, 2, and 3. It is only 0 and 1. Let's take a look at the range of this function. Well, we know that set B has 5 objects in there. So let's list them. It's got 0, 1, 2, 3, and 4. But not all of these are part of the range. The range are only the objects that serve as images. And there's only 2 objects that have a connection. So the range only includes the 1 and the 3. Those are the only 2 objects in the target set that have connections. And this is the difference between domain and range. Alright, let's take a look at another very interesting example. I would like you to put EX, please. Alright. Now, I would like you to draw the following graph. I would like you to pause the video and draw this. Go ahead, pause the video and do it now. Alright, let's take a look at this graph and determine what our domain and range are. Well, remember the definition of a domain. A domain represents the source set. The source set represents the independent variables. So we are looking for items on the x-axis. So ask yourself, as part of the domain, which values are on this graph that form part of the x-axis? Well, let's take a look starting from the left. If you take a look at the first point, the x-coordinate is -2. That's part of the graph, so that's part of our domain. So let's list it down, -2. Let's keep going. The second point, the x value there is -1. That is part of the graph, so let's list it as part of our domain. Let's keep going. The third point is located at x equals 0. That forms part of our domain also. So x equals 0. The fourth point has x equals 1. So, part of our domain. Let's list it. And there's one more point to go. And this point has an x-coordinate of 2. Let's put it down in our domain. So this graph has 5 actual x values. -2, -1, 0, 1, and 2. Okay. Let's take a look at what elements will make up our range. I'm just going to erase the arrows here. Alright. Now, don't forget that the range refers to the target set, and the target set represents the dependent variables, and the dependent variables is referring to the y-axis. So when we're asking for the range, we're asking for which y values form part of the graph. So let's take a look. Again, let's start at the lowest point. Let's look at the first lowest point over here. What's the y-coordinate for that point? It's 0. So let's list that as part of our range. Let's keep going. Look at these two dots, or points, excuse me. These two have the same y value. Both of them have y value of 1. So that means the 1, y equals 1, is part of our range. Let's list it down. And the last item that forms part of the range, look at these 2 points, all the way at the top. They have a y value of 4. So that means that the 4 is part of our range, because it's part of the graph. So, let's keep going. I want to do another example, and you're going to see something very, very strange. The x. Now, we're going to draw a similar graph to the previous example. I would like you to pause the video and draw the following graph. You'll notice that the same points show up in this graph as in the previous example. But there's one big difference. I connected all these points, whereas in the previous example, the points were not connected. So go ahead, pause the video, and draw it now. Alright, now let's take a look at the difference between this graph and the previous graph and how that affects the domain and the range. So, let's look at the domain. The domain, remember, are all the elements on the x-axis that form the graph. Well, let's start on the left side here. It starts at x equals -2, and it keeps going in a continuous curve all along the x-axis. There's no gaps, and it keeps going, and the x values stop over here at this tip of the parabola at x equals 2. So that means our domain starts all the way at -2, goes all the way to +2, and it includes everything in between because I connected all the points with a solid curved line. That means our domain is starting from -2 and goes all the way to 2 and includes everything in between. Very interesting. You see the difference between this graph and the previous graph. The previous graph did not have all the points connected. So the x values had gaps in there. It was not one continuous range. But the moment you connect them with points, you have one continuous range. Now let's look at the y values. Again, if you take a look at the y values, the lowest point that it starts at is y equals 0. And it goes continuously all the way up to the highest point, which stops at y equals 4. There's no gaps in between. That means that our range goes all the way from 0 all the way up to the highest point, which is 4, and it includes everything in between. It's a big difference when the points are connected with lines or curved segments. I would like to take a look at another very interesting example. So, I could put another EX. I would like you to pause the video and draw the following graph. Go ahead, pause the video and do it now. Alright, let's take a look at the domain and range of the graph I just gave you. So, the domain, I remind you again, the domain refers to the source set, which refers to the independent variable, so we are looking at the x-axis. Ask yourself, how far left does the graph start to how far to the right does it go to? Well, take a look. The x value first starts at x equals 1. So as part of the domain, starts at 1. And the line, there's no gaps in it, so it keeps going, it's everything in between, and it stops at this point. There's no more x values beyond that. Now be careful. That is an open point, which means that the x value at that point is actually not included. So the x value there is 4, and the bracket has to indicate that it's not included. Now let's take a look at the range. Now don't forget, the range refers to the target set. The target set refers to the dependent variable, which is always located on the y-axis. So the range, ask yourself, how low does the graph start and how high does it go? Well, let's take a look at the lowest point. The point right there. As you can see, the lowest y value is 1. So the range starts at 1. And how high does it go? Well, the line is a continuous line. There's no gap in it. And it stops over here at the open point. There's no more y values beyond that. And the highest y value that it goes to is 3. And because it's an open point, the 3 is not included. Very interesting graph. Look at one final example. Let's just put EX. I'd like you to pause the video and draw the following graph. Go ahead, pause, and draw it now. Alright, let's figure out the domain and the range of the graph I just gave you. So, one final reminder that the domain refers to the x-axis. So you're asking yourself, for this graph, how far left does the graph start from, and how far to the right does it go? Well, let's take a look. The leftmost x value starts right here. And that x value corresponds to x equals 0. And it is one continuous curve. There's no break in it. And the x values stop here. That point corresponds to x equals 5. That's our domain. This graph starts at 0, stops at 5, and no stops or gaps in between. Now, let's figure out our range. The range, one final reminder, talks about the y-axis. You're asking yourself, how low does the graph start at and how high does it go? Well, the lowest point is over here. And that corresponds to a y value of -2. How high does this graph go? Well, it keeps going, keeps going, keeps going, and the highest point that it reaches is right here. And that point corresponds to a y value of 3. So the range of this graph means that the graph starts at -2, includes everything in between because the curve has no gaps in it, and it stops at the highest point, which is y equals 3. So there we go. That is what is meant by the domain and the range of a function.